Okay, so today we are going to look at lesson 4.4, and we're going to use our factoring skills and solve equations, quadratics, by factoring. So here are all of your procedures for solving a quadratic equation. So first you're going to move all terms to one side and set the equation equal to 0. So I like to move things to where x squared is positive. That just makes it easier for factoring. So then once you have everything over on one side and one side equaling 0, then you're going to factor. Then you'll set each factor equal to 0 and solve for x. I'll show you why in a minute. And then you're going to write your answer as a solution set, and I'll show you what I'll accept for that as well. I'm not too picky on that particular one, shocking but true. So I'm not going to do all the problems in these notes. If you want to look at them worked out, they're online. But I'm going to do a few of them here today and have you work on a few of them on your own and pause the video. Same type of stuff I normally do. So let's start with number 1. So for number 1, the first step, getting one side equal to 0, is already done for you. Then the second step is to factor this. So you're just going to use our factoring rules that we've had before. The very first question that you ask yourself, is there a greatest common factor? Yes, there is. Both of these have an x in common. They don't have a number in common, just an x. So I'm going to divide both terms by x, and then that x is coming out in front of the parentheses. Then just perform your division. X squared divided by x is x. 9x divided by x, the x's cancel, is just 9. Then the third step says to set each one of these factors equal to 0 and solve for x. Well, the question is why? I have something times something equals 0. If I've got two things being multiplied and their product is 0, for that product to be 0, either this has to have a value of 0 or this has to have a value of 0 to get a product of 0. So I want to find out what will make x 0 and what will make x plus 9 0. So I'm going to set the factor of x equal to 0 and the factor of x plus 9 equal to 0, and then I'm going to solve this for x and this for x. This one's already solved for x, so there's not anything to do for this one. So one of our values is 0. Then the second one, if we subtract 9 from both sides, then your x is going to equal negative 9. So we have two solutions, x equals 0 and x equals negative 9. So you can write them this way or as a solution set. I don't care which way. Now the question is, what does this mean? So I could ask you to draw a sketch of this parabola. And so you know that with this parabola, that one of my answers is negative 9 and one is 0. So that means that my problem must cross the x-axis here at 0 and also somewhere around here at negative 9. And so I can go ahead and just estimate where that is. Here's 0, and here's where negative 9 would be. And then you know that the graph opens up because the x value, or the x coefficient, is positive because it's positive 1. So it must open up. So our vertex must be somewhere here below the x-axis. I don't know where, but we're just going to sketch it. It's ugly but true. There's a sketch of my parabola. Okay, so what I want you to do is number 2 on your own. So go ahead and pause the video and complete number 2 and then restart the video. All right, so hopefully you pulled out the greatest common factor, which is 4x. So I'm going to divide both of these by 4x and take that 4x out in front of parentheses. I'm going to change my pointer back to my little hand. So the 4's are going to cancel, and then x squared divided by x is x. And then negative 8 divided by 4 is negative 2, and the x's cancel. So I get minus 2. So then I need to set this equal to 0 and this equal to 0. So 4x equals 0, and x minus 2 equals 0. Now solve for x. So for the left one, I'm going to divide by 4. And then 0 divided by 4 is 0. So there's one solution. And then on this one, we're going to add 2. And we get x is equal to 2. So that means that my graph is crossing the x-axis at 0 and 2. So if I asked you to sketch that, you would plot a point at 0 and one approximately at 2, and my graph opens up because A is positive. So my vertex would have to be below the x-axis. So here's just a quick sketch of that parabola. All right, so number 3. So number 3 is different than 1 and 2. And the reason why it's different is because there is no greatest common factor to take out. I have one side equal to 0, but no GCF. So you're going to ignore this side and just factor this. The only binomial that we can factor, if we don't take out a GCF, is the difference of two perfect squares. So this is the difference of two perfect squares. And as soon as you identify that, you can set up your plus minus pattern. So you're going to take the square root of x squared, which is x, and the square root of 4, which is 2. And now you're going to set each one of those equal to 0. And then solve for x. So I've got x equaling -2 and +2. So go ahead and try number 4 on your own. Pause the video and then restart it. All right, so number 4 is also the difference of two perfect squares. So it gets that plus minus pattern. The square root of 9x squared is 3x. And the square root of 25 is 5. So when you set these equal to 0, the solution's a little trickier, but not all that much. So we're going to subtract 5. And divide by 3. So this one we are going to add 5 to both sides. And then divide by 3. And so there's your two solutions for those ones. Then let's look at example 5. Example 5 brings us to a trinomial. You still have one side equaling 0, so step 1 is checked. Then over here, look for greatest common factor. There isn't one. And since there's not, it's a trinomial, there's nothing in front of here, so I don't have to swing multiply. I can just find the factors of 21 that add to give me 10. So 1 and 21 add to give me 22. And 2 doesn't go in there. 3 and 7 add to give me 10, so that's what I'm looking for. My 10 is negative. The bigger of the two is negative. The 3 is going to need to be negative to combine with this -7 to make -10. So then here's my two sets of parentheses. X squared is x and x. And then I put in a -3 and a -7. There is no need to divide by anything because we didn't multiply by anything and change the equation. So we can just set these equal to 0. And then solving. So I get 2 solutions. So now you try 6 on your own. Pause the video, factor, look for greatest common factor first, and then factor. Okay, so hopefully you discovered that there is a greatest common factor of 2. So we're going to take this out in front, and we get x squared minus x minus 12. Now, because this greatest common factor of 2 doesn't have a variable in it, I can actually divide both sides by 2 to get rid of it. If there had been a variable in it, like 2x, I would not be allowed to divide by anything that has a variable in it. And so that's going to cancel, and I get x squared minus x minus 12 equals 0. So once again, if this GCF has a variable in it, you cannot divide it to both sides. So now I'm left with finding the factors of 12 that subtract to give me 1. So 1 and 12 subtract to give me 11. 2 and 6 subtract to give me 4. 3 and 4 subtract to give me 1, and that's what I'm looking for. So the sign of my 1 is negative. The sign of the 4 is negative. The 3 is going to have to be positive. So now you can put those in parentheses. And then you can set those equal to 0. And then solve. There you go. All right, the last one on this page that we're going to do is 8. And so with 8, you can go ahead and pause the video and try it if you would like, but I'm just bringing this one to your attention because it does require the swing factoring. There is no GCF. So you can pause the video or go along with me. All right, so we are going to multiply the 6 to the negative 4 and create a new trinomial. 6 times negative 4 is negative 24. Because we multiply by the 6, we're going to have to divide by 6 at the very end, so don't forget that. So we're going to take the factors of 24 and subtract to find 5. So 1 and 24 give you 23. 2 and 12 gives you 10. 3 times 8 is 24, and that does subtract to give you 5. So my 5 is positive, so the 8 is positive. The 3 is going to have to be negative. So I get, I get x minus 3 and x plus 8 equals 0. Now before I can set those equal to 0, I have to finish my factoring. And since I multiplied by this 6, I'm going to have to divide by 6. And anytime this fraction here can be reduced, you must do so. So because 3 and 6 are both divisible by 3, 3 goes in here negative 1 times, 3 goes in here twice. Now I can pop this 2 in front of the x, and I get 2x minus 1. Then the 8 and the 6 have a 2 in common, so I'm going to divide 8 by 2 and 6 by 2. And so now I can pop this 3 in front, so I get 3x plus 4 is equal to 0. Now set your factors equal to 0. And solve for x. So you get two solutions, one that is 1/2 and one that is -4. All right, so now we're going to look at the next page. Let me make these bigger and straight. There we go. Okay, so starting with this page, these are going to look a lot different than the first 8. And the reason is they are no longer solved for 0 for you. So you're going to have to get 0 on one side. So remember, always move everything towards the side where your x squared term is going to end up positive. So for instance, for 9, we're going to move this 5x to the left by subtracting it. So you still have to use proper algebra. But when I subtract the 5x on the left side, these are not like terms. They both have an x, but this is x squared and that's x, so I cannot combine these. And so you write highest degree term, 2x squared, first, minus the 5x equals the 0. Now this is just like problem 1 and 2 on the previous page. So now go ahead, pause the video, solve it, and restart the video. So hopefully you realize that they have an x in common and only an x, so that's going to get pulled out in front of parentheses. And then the 2 doesn't have anything to cancel with, so it stays at 2. X squared divided by x is just x. The x is going to cancel and you're going to be left with -5. So then set those equal to equal to 0. So you get x is equal to 0 and 2x minus 5 is equal to 0 and solve. Well, this one's already solved, so it just leaves this one to solve. So I get 2x is equal to 5 and x is equal to 5/2. So those are the two places that your graph is going to cross the x-axis, 0 and 5/2, which is 2.5. All right, so you try number 10 on your own. Pause the video and then restart it. All right, so be careful with number 10. Remember, we want 0 on one side. You cannot take out a greatest common factor. I know they all have an x in common, but you cannot take out a greatest common factor until you've moved everything over to one side and you have one side equal to 0. So your first goal is to move things. So because this is bigger than this one, this is smaller, I'm going to move this one over here so my x squared remains positive. So I'm going to subtract an x squared and subtract an x squared. 7 of these minus 1 of these is 6 x squareds. The variable string doesn't change. Bring down the 8x equals 0. Then from here, they have a GCF of 2x, and I'm going to bring that out in front of parentheses and do my division. Well, 6 divided by 2 is 3. X squared divided by x is x. 8 divided by 2 is 4. And then the x's cancel. So then I'm going to set each of these equal to 0. So 2x equals 0. And 3x plus 4 is equal to 0. Solve by dividing by 2. So I get x is equal to 0. Subtract 4. 3x is equal to -4. X is equal to -4/3. Now let's look at number 11, only because it looks a little trickier since you have 2 things here and 2 things here. So where do I move things? Concentrate on your highest degree terms, which are your x squared terms. This is bigger, this is smaller, so we always move the smaller. So we're going to move this one over here, so that means we're going to move the -1 over here as well. So to move the x squared, we're going to subtract it. Squared, that's an actual 2. That's terrible. I can do better than that. Okay, so then the x squareds here cancel, and then in addition, I want to move the -1 by adding 1 to this side, and so I add 1 to that side. So 2x squared minus 1x squared is going to be a positive 1x squared. Negative 50 and a positive 1 is a negative 49 equals 0. So this side needs to be factored. There is no GCF, but it is the difference of two perfect squares. So it factors into that plus minus pattern. So you get x and x. Why? Because I took the square root of x squared, and then the square root of 49 is 7 and 7. So then set x plus 7 equal to 0, and x minus 7 equal to 0. I'm going to subtract 7 and add 7. And I get x is equal to negative 7 and positive 7. All right, so the last one on this page that we're going to do is 16. So you could either stop the video and try 16 on your own, or you can go through it with me. So it's your choice. So here's my highest degree term. It is the only x squared term, and it is positive. So that means these two things are moving over here. So I'm going to move the 2 by subtracting 2 and subtracting 2. I'm going to move the negative 3x by adding 3x and adding 3x. So I get a 4x squared plus 44x plus 96 is equal to 0. Now you can look for greatest common factor. This has a 4 in common, so all three of those can be divided by 4. All right, so the 4's cancel and you're left with an x squared. 44 divided by 4 is 11, so positive 11, tack on the x. And then 96 divided by 4 is going to be 24. Now remember, if this GCF does not have a variable, I can divide this side and divide this side by that GCF. So I'm going to divide this side by 4 and divide this side by 4, so I can just ignore it. And so I get x squared plus 11x plus 24 equals 0. So now I need to factor the left side. So I'm going to take the factors of 24 and add them to get 11 because there's no coefficient in front of here. So the factors of 24, and it's positive, so I'm adding them, and I'm looking for positive 11. So 1 and 24 add to give me 25, 2 and 12 add to give me 14, 3 and 8 add to give me 11, and that's what I'm looking for. So my 11 is positive, so the bigger of the two is positive. The 3 is also going to have to be positive. So now I'm ready to put those in parentheses. So x plus 3, x plus 8 equals 0. And then we're going to set these equal to 0. And then solve. And then subtract 8. So I get 2 solutions. Okay, then we're going to only do 2 more, so let's look at the next page. So on this page, it's really rather tiny, so you can see your whole page, but I'm going to expand this and make it bigger, so you're only going to be able to see parts of it at a time on the video, on the video itself. Pardon me. Okay, so Standard form, if you recall, is y equals ax squared plus bx plus c. So we're essentially going to be reviewing everything that we've done for the last few days. Vertex form is going to look like this. Y equals a times x minus h squared plus k. And in this, your vertex is h comma k. So one thing I want you to notice about the vertex, it's h and k because there's already an x and a y used in here. And so this calls for the opposite of h from here. So notice that this is h, but this is the opposite of h. So whatever h is, you're going to change its sign and put it here inside the parentheses. Whatever k is, you're going to keep it just the same. So let's look at the equation that they have given us, and we're going to look at the standard form, and we're going to find a, b, and c. So a is your coefficient of your squared term, so that must be 1. B is the coefficient of your x terms, so that is negative 8. And c is your constant, which in this case is 15. So if I want to change, because right now I have standard form here, but I want to find vertex form. So to find vertex form, all I need is the vertex, because the a here is the same as the a here. So if my a is 1, then the a here is also going to be 1. So that just leaves me having to find the vertex. And you already know how to find the vertex. You just have to use the opposite. Whoa, that was weird. You just have to use the opposite of b over 2a. So that's what we're going to do. I'm going to start by finding the vertex. So the x value of the vertex is equal to the opposite of b over 2a. So the opposite of b over 2a. Now my b is negative 8, and my a is 1. So I end up having the opposite of negative 8 is positive 8. 2 times 1 is 2, so that equals 4. Then my y value of the vertex, we're just going to plug into the equation. Wherever you see an x, we're putting in substitution parentheses. So I'm just going to take this value for 4 and I'm putting it here and here. So 4 squared is 16. Negative 8 times 4 is negative 32 plus 15. 16 and 15 is 31. 31 and negative 32 is negative 1. So this has become my h, and this is my k. So this is the x value of my vertex h for here, and this is my k. So we're ready. We're just going to put into our vertex form. So all I need to do is put in my a. Well, my a is 1, so I'm going to put 1 here. And normally I wouldn't write 1, but for our note purposes, I'm going to write a 1. Then here is the opposite of h. Well, if h is 4, the opposite of 4 is negative 4. So I'm going to put in a minus 4. And then we put in positive, the k exactly as we see it. So k here is negative 1, so we use exactly what we see, negative 1. So only the x value changes signs, not the y value of the vertex. And that's it. That is the vertex form of a parabola. So you can actually see the vertex in vertex form. So it's the opposite of what you see here, 4, the same as what you see here, negative 1. So now we're going to plot. We also have to factor. We're going to do that also in a minute, but I'm going to gather some more information. So a couple things that I know. I know that my parabola, let me see if I can get a better color. All right, so I don't know if I like that color. We'll use this one, like a lime green. So I know that my parabola opens up. The reason why it opens up is because A is positive. Since it opens up, it has a minimum value. The vertex is at the bottom of the parabola. And if you recall, we get two things from our vertex. So the x value of the vertex gives us our axis of symmetry, and the y value gives us our max or our min. And so in this case, our minimum is going to equal -1. And then our axis of symmetry is an equation, and it's going to be x equals 4. So 4 is the x value of the vertex, -1 is the y value. Then the other thing I want to gather is the y-intercept. If you recall, the y-intercept is 0, c. So c in this case is 15. All right, so now let's look at the factored form. So I'm going to take the original equation, which is, and I'm going to let f of x or y equal 0. So 0 equals x squared minus 8x plus 15. And what the factored form is going to give us is our roots, or our solutions, our x-intercepts. So we don't have a GCF, and there is no number in front of the x squared, so we don't have to multiply. So we're just going to find the factors of 15 and add them to get -8. So 1 and 15 adds to give us 16, and 3 and 5 adds to give us 8. So my 8 is negative, so the bigger of the two is negative. The 3 is going to have to be negative as well. So we get 0 equals x minus 3, x minus 5. Set each of those equal to 0. And solve. So these are our x-intercepts. So now we are ready to plot everything. So I'm going to graph everything over here. I'm going to make this just a smidge bit bigger. All right, so the first thing I like to plot is my vertex. Let me get some different colors. So my vertex is at 4, -1. So right here. And then my axis of symmetry is going through that vertex, and that is x equals 4. Then I'm going to plot my intercepts. So my intercepts are at 3 and 5. And then I would normally try to plot my y-intercept just to get some shape to my graph. But my y-intercept is at 15. And this graph goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can see I'll be way past it. So I'm not actually going to graph that. But I am going to connect my points right here. So that is what my parabola looks like. That's the graphed form, and as you can see, it does indeed open up, and it does indeed have a minimum value here. The only other thing that we haven't talked about is domain and range. So domain is always for these -infinity to +infinity, because this is going to go infinitely to the left and infinitely up and to the right. The range is limited by the max and min value. So because we have a minimum, it is going to go here on the left. And our minimum value was the y value of the vertex, which is at -1. And then it should go to +infinity. In other words, down here, going from down to up, there's no graph until I hit this point at which the y value is -1. So the very smallest y value is -1. That's why it's a minimum. And the graph is going infinitely up. So it's going to go to positive infinity. All right, the last problem we're going to do is the second one here. And then I want you to pause the video and try to do all of that on your own. And then I am going to do the problem as well. So you can pause the video and off you go. Okay, so for our purposes, I need to know A, B, and C. So A is -2, B is -4, and C is 6. I know a few things. I know that my parabola opens down because A is negative. So because it opens down, I have a maximum, and we will find that maximum in a minute. I also know my y-intercept. My y-intercept is 0, 6. And I know all of this before I've done anything. So then I want to find the x value of my vertex. So the x value of the vertex is the opposite of b over 2a. So you get -1, and then we're going to plug it into the function. So be careful when you plug this in over here. It is not -2 times -1 and then squaring it. You have to square the -1 first. So -1 squared is 1 times the -2. You get -2. -4 times -1 is +4 plus 6. 4 plus 6 is 10, minus 2 is 8. So our vertex is -1, +8. And so that also tells me that our maximum value is going to be 8. Why? Because the y value of the vertex is our maximum value. And then I also know my equation for my axis of symmetry. So axis of symmetry is x equals -1. So this gave me this, and this gave me this. All right, so now we have everything we need to write the vertex form. So the vertex form, if you recall, and you can also see it above, is y equals a times x minus h squared plus k. So my vertex is -1, 8, which means that this is my h and this is my k. And then my a, from what we did before, my a is equal to -2. So we have everything we need to plug in. So I have y equals, and then the x, and everything else is getting plugged in. So I am putting in -2 for a, and then remember that this is the opposite of h. So if h is -1, I'm putting a +1 in here. And then k is exactly what it is, so I'm putting in a +8. So this is my vertex form. And then all I have left to do is factor. So my original was, I'm going to change f of x for 0. So my original problem was -2x squared minus 4x plus 6. So you can either factor out a -1, actually I'm going to factor out a -2 because I don't want my x squared to be negative, and they all have a 2 in common, so that's what I'm going to start with. So I'm going to divide out a -2 and pull that out in front of parentheses. And I get x squared plus 2x minus 3. And because that GCF does not have a variable in it, I can divide this side by -2 to get rid of it, and this side. If there was a variable in it, I would not be able to do that. So I end up with 0 equals x squared plus 2x minus 3. And so now we're ready to factor. So I don't have anything in front of here, so I'm going to take the factors of 3 that subtract to give me 2. So 3 is negative, so that's why we're subtracting. And I'm looking for positive 2. Well, there's only one set of factors for 3, and fortunately they subtract to give you 2. So my 2 is positive, so the bigger has to have that sign. The 1's going to have to be negative. So 0 is equal to x minus 1 times x plus 3. Set each one of those equal to 0. And solve. So I get x is equal to 1 and x is equal to -3. So here are my solutions, and these are my x-intercepts. So I have everything I need to graph. So let's go ahead and graph. So my vertex was -1, +8. My axis of symmetry goes through that vertex. My x-intercepts were -3 and +1. My y-intercept was 0, 6. And then I can reflect this point across the axis of symmetry. So this is 1 unit away. I'm going to reflect it over here. And so this is my reflected point. And so that reflected point is -2, +6. And now we can connect. Oops, I almost missed that one. And that is the graph of our parabola. So that's everything. What a thing of beauty. All right, so that's a review of everything that we've done this week. So get your homework done. If you have questions, please ask.